Everyone, welcome back to the channel. My name is Drew. Apologies, it's been a week or two since I did our last video. I've been working on a big assessment for my PhD, which I'm happy to say I passed. So on to the next phase. Anyway, so today's video, we are looking at motor unit recruitment and the all or none principle, which is a really important one to understand in terms of training and how to develop muscular strength and endurance, and why the principle of progressive overload is really important. Okay. We are using Yoga Muscle and Motion app. You'll find the link to the app in the description. I don't get any kickbacks from these guys. I just think it's a really great app. They have a yoga app, they have a posture app, and they have a strength training app, and they're all fantastic. If you're a visual person and visual learning is your go, I really recommend jumping in and getting the app. So let's jump in here. So I'm in the theory section and we're in muscle physiology, and you'll find this in the muscle physiology section. And as always, I'm not going to go through the whole thing. I want you guys to support the app by buying it, but we're going to go through the key concepts here. Let me just adjust this camera a little bit. There we go. You can see more of my buff head. I've got my amber light here. It's in the evening, so just getting my red light properly done, maintain my circadian biology. So we're looking at the nerve signals that are coming down from the central nervous system, the brain. Prefrontal cortex and the occipital region is usually where the motor signals come from the brain down to the spine. So we see here, brain, the yellow is the spine, so that's the central nervous system. You'll generate an impulse, a thought to contract a muscle, and usually that thought starts in the brain. Okay, so before action, there is usually a sensory perception, and then an emotion, and then a thought, which then triggers the action. Okay, so depending on which region of the brain here, this is the occipital region, it's going to come down, and here we're going to go access into one of our rotator cuff muscles, infraspinatus. So we have nerves that are coming down from the cervical spine. So here we're looking at the C2, C3 nerve root, which comes down, and it's going to connect to this muscle here. Okay, so where the nerve connects to the muscle is called the motor unit. So think motor as in action, and unit because the nerve's going to branch off and it's going to connect a lot of muscle fibers. So it creates like a little group or a unit that works together. Okay. Now within the spinal cord itself, we have, broadly speaking, the alpha motor neuron, which comes from the spinal cord ventral horn. Okay, so that's the signal from the spinal cord to the muscle. Okay, and then as the spine nerve comes out, it's going to then bifurcate, and then you have a little nerve that connects to each individual muscle fiber. So this is the motor unit. Okay, and you can have multiple motor units branching off a nerve to multiple fibers within the muscle. So if you look at a muscle biopsy, you can see there's big groups of muscle fibers connecting together. And then where the nerves terminate into the actual muscle fiber, that's called the terminal branch. That's where it ends, or the end plank junction. Okay, and that signals what's caused the muscles to contract. So pretty much every muscle in the body will have a nerve that connects to it. And then depending on the size of the muscle, you might have really fine motor units. So think of your eye muscles, or if you're looking at your leg, you might have really huge motor units that connect to the leg. So bigger the muscles, you're going to have a lot more motor units and a lot more nerves branching off into the actual muscle themselves. Okay, so here we get to the all or none principle. So the signal coming down the nerve is an electrochemical signal. So it's a electrical signal that's gated chemically. So the chemical kind of component is sodium potassium. You may have heard that. So you have different levels or concentrations of sodium and potassium inside the cell and then outside the cell. And the differences between the two sodiums increase the potential voltage or the charge. So remember, you've got an electrical signal coming down the nerve. So then as the sodium potassium gates kind of open and you get influx of sodium in and then outflux of potassium out, or vice versa, then the voltage in the cell changes and it needs to hit a threshold for the actual electrical signal to kind of keep propagating down the nerve into the muscle. So you need a certain level of charge or voltage before you can kind of activate or turn on the muscle. So when you hear terms like muscle activation drills, that's kind of what they're referring to. Is there enough power or voltage to actually turn on or meet the threshold where it's going to signal the muscle to contract? So typically that threshold is going to be around negative 55 volts. Once you get past that, so you increase the charge past 55, you're going to get that voltage and you're going to get that electrochemical charge into the muscle fibers, and then that's going to stimulate the muscle fibers to contract through another complex kind of biochemical process, which you might do another video on down the track. Okay. So here we have you doing a squat. There we go, nice little squat action. So big muscle group here, we've got the quads in the squat, of course, and the glutes. So you can hear this could be like the sacral plexus, so the muscles coming out of the lumbar spine and the sacrum going to the glutes and to the quads. So you've got multiple branches of nerves coming down. And then you have multiple motor units connecting to each one of these kind of bundles of muscle fibers. Okay, so you've got these various bundles. So in the muscle, you have the individual muscle fibers, then you have bundles of muscle fibers, and then you have bundles of muscle fibers, and then you have muscle bellies themselves. And each one of those is wrapped around with fascia and connective tissue to keep it all kind of together and in position and to give it shape, form, and structure. And so when we do a video on fascia, we'll go into that in more detail. But you can just see here, you've got these different kind of bundles of muscle fibers connected. So the motor unit that comes down to all the nerves that connect to these muscle fibers, that creates the motor unit. So when you get voltage come down, if it gets past that 55 negative voltage and it achieves enough to generate the action potential or the nerve signal, then it's going to stimulate all of those fibers to contract that's connected to that motor unit. So if you're doing squats, if you're starting off, for example, and you're doing body weight squats, initially what happens is the body's going to sense how much force it needs to generate to contract your glutes and your quadriceps, how much of these muscle fibers you actually need to kind of turn on to contract to produce mechanical force to then make you squat up and down. Okay. So when you're starting off, because the body's really conserves energy really well, it's going to use the least amount of muscle fibers or motor units it needs to execute to get the task done. So it's going to use the least amount. So it's really, really efficient, which is great because you don't want to have all this wasted energy, because every time you contract a muscle, there's a metabolic cost. It consumes glucose, it consumes fat, it consumes oxygen, and you require voltage to make it all work. So there's a metabolic cost to that. So you do, let's say you do a set of 10 squats and the body kind of figures out it only needs to activate 2 of these motor units to generate enough force in the quads and in the glutes to be able to contract the muscles for you to move up and down in a squat against gravity. Okay. Then all of a sudden you decide you want to increase and you want to do 20 squats. Okay. So as you generate and use these muscle fibers, as you are using the energy source in the tissue that requires ATP, oxygen, glucose or sugar or fat, as they get used up, they get depleted. And there's a cycle that happens where they get restored. But if the demand outstrips the use, then they're going to have to get more motor units or more muscle fibers to be recruited to make up the demand. So then it's going to activate or bring in more motor units. Okay, so that's one way you're going to increase the activation of muscles. The other way, if the central nervous system senses that it's going to require more strength, more force production to move the load, then it's going to bring on more of these motor units as well. So the first activation is going to be just turning it on to meet the demand. The second activation is going to be if you increase the intensity, either the load or repetition, particularly when you increase the load, then you're going to start to activate more of these muscle fibers. And so the body's going to use more and more of them. And this is what progressive overload does. So as you progressively increase the intensity with repetition or with load or decreasing rest periods, then the body's going to have to activate other motor units to keep doing the work, to keep doing the load. Now, this works really well with strength training. So as you're doing strength training, so if you start to load up the squat with a barbell or dumbbells and you're adding load to it, it's getting heavier, so you're going to need more muscles. And this is where we get into what bodybuilders will do. So the bodybuilder is going to try to overload the entire muscle. So what a bodybuilder program will look like, say if you're looking at quads or leg day, they may select 3 to 5 leg exercises, which target the quadricep muscle group. And they'll select different positions, which have different angles and different loading profiles, which are going to put the forces or the tensions into different parts of the muscles primarily. So then it's going to make that part of the muscle contract. So for example, if you do a barbell back squat, okay, the load in the barbell back squat tends to go a little bit more into the glutes and a little bit more into the quads evenly, if you will, because it's coming down through this kind of line in an even fashion. But if you do a front rack squat or a rack squat or a goblet squat where the weight is forward, then the load is going to come down more to the front. And so the quads are going to take more of the loading. And so that becomes quad dominant, right? So depending where the load is coming down and the angles of the joints, you're going to kind of like preferential kind of target or load those tissues. So when you execute the exercise, that region of the muscle has to take on more of the load. Okay, so then you recruit more muscle. So in the bodybuilding type of program, what they're doing is selecting multiple different exercises, multiple different angles and body positions and joint angles to recruit as much of these muscles as they can so they all get hypertrophied, so they all grow in size, or you grow more muscle fibers to make the muscle bigger. That overloading stimulus is, the volume is a lot, so you're looking at depending on which protocol you use, like 16 to 20 reps, 5 to 6 sets. Okay, good rest periods between sets. And that's one exercise, and then you might select 3 to 5 exercises on that workout. You will be sore for days afterwards as you adapt to these workouts. So you'll often see bodybuilding or bodybuilding type programs where they'll have specific body parts or regions where they'll train on specific days with long breaks in between. And that allows the healing process, recovery process of the tissues. Okay. So, and you really want to work with a good strength and conditioning coach, someone who's into bodybuilding, understands programming really well and functional overload, so they can guide you through that process. Because if you jump into this too quickly, all you're going to do is make yourself incredibly sore and potentially injure yourself. All right. But that's essentially, from the nervous system perspective, that's how we get stronger as we stimulate the muscles and with more intensity. Then the muscles have to bring on more muscle fibers, and then they get activated via the central nervous system. So that's your activation. And then that's how we start to recruit more muscles. And when the muscles start recruiting, then they will develop, because then they'll get that stimulus to hypertrophy and grow bigger. So that's kind of the concept underneath that. The other kind of concept you want to appreciate is inhibition. So we have in exercise physiology reciprocal inhibition. So for example, this nerve plexus that's coming down to the quadriceps, for example, here, there's a reflex arc that goes from the quadriceps back into the spine. So basically think of nerves coming from here, going back to the spine, and then from the spine to the opposite muscle group, what we call the antagonist, or the opposite muscle group, in this case it would be the hamstrings, to signal the hamstrings to relax when the quadricep muscles are contracting. All right, because if the hamstrings contract at the same time as the quads contract, then they'll cancel each other out and you won't move. They'll both contract isometrically, but you won't generate a movement. So for us to be able to move, then we have to have what's called reciprocal inhibition. So that's a really normal, natural, functional part of human physiology. Now, the problem is if you get an injury, or if you develop a posture, or if you do a poor training program, where all you do is train quads and they get bigger and bigger and stronger, and we don't train the hamstrings, essentially what can happen is, because you're signaling that hamstring to relax all the time, and you're not doing counterbalance training where you strengthen the hamstring, you can create a pretty powerful imbalance in the muscular system. And then eventually, if this quadricep gets tighter and tighter, it will continually inhibit or weaken or decrease the activation, the neural connection to the muscle. And so it just can't generate force because it's not getting as much action potentials coming down, because it's partially inhibited due to the position of the quad, or the partial contraction of the quad, or the position of the pelvis. And so that we call that reciprocal inhibition. And in rehabilitation, that can be a really big problem. So if posture is in the wrong position, which then creates a position where one muscle is in a short and tight position, it's contracted. Okay, if you contract that muscle, it's going to signal the other muscle to relax. So then you create a muscular imbalance. And in the kind of therapy space, there's this kind of big movement about the posture's not a thing. And to be perfectly honest, that's absolute rubbish. Like, posture is so important. It's the balance and the communication between these muscles, which is really, really key. So you can sit in I'm in a slight slouch position. That's no problem. Okay, that's what they're talking about really, is like, oh, these postures are bad. You need to be a sit upright in great alignment. You can't do that all the time. It's impossible. What you need to do is have a really balanced program where you're training front and back, up and down, inside, outside. So you're training muscle groups and agonists, antagonists. So put simply, if you do a chest day, a push day, you must do a back day, a pull day. If you do a quad day, a squat day, you must do a hinge, hamstring, glute day to keep everything balanced. And that's the art and science of programming. If you do that really well, you'll have a really, really balanced body. And then a lot of niggling pain and dysfunction will just disappear, because everything is working in the right balance, the right sequence. Muscles are getting good neural drive, neural activation, so they can turn on and then they can relax. Just as important. So everything works well together. And if you can get that working, then everything's happy. And then you can kind of step up into either fitness or performance training, depending on your goal, or just live a happy, pain-free life, which is pretty good in itself. So I hope that video was helpful for you. If you like the video, if you have any questions, like for the thumbs up, questions in the comments. And, if you know someone who might benefit from this, please share it around. All right, I'll see you in the next video. As always, stay humble, keep learning, keep training, and be happy. Okay, and let's stop this one.